Hi everyone. My name is Simeon Lukov. I'm founder and CEO of Dynamic Pricing. And today I'm going to present a new kind of database called BanditDB. And I just wanted to ask the audience, um, is there someone that is familiar with contextual bandit and bandit framework? Okay, good. Uh, okay, so let's get started. The idea of bandits in general is to give any system a feedback loop and learn from experience via rewards and penalties. And this is quite applicable for many situations, even in life. So if you think about choosing in restaurant, you have your favorite restaurant, you go there, but sometimes you want to try new restaurant, and this is how you learn if this new restaurant is good or not. Or if a doctor wants to prescribe a new drug, they don't know what's the right dosage, so they try like 50 milligrams or 100 or 150 for different people, and this is how they understand what's the right uh, dosage. And we use it also for dynamic pricing because we do price testing. We put products on different prices, and we try to sell on a higher price, for example, or to find the optimal discount so that the merchants are not needed to discount deeply, but like they can sell products with 50% discount, not with 50% discount, for example. And the idea is the basic idea of bandits and multi-arm bandits is this exploration and exploitation dilemma, and the time uh, about learning for something and then experience after learning. And the usual way of testing something new is A/B testing, but A/B testing split everything on equal amount, like 50-50%, which is not ideal because 50% of the time you are with the wrong medication, wrong restaurant, wrong price, whatever. And that's why people were searching for something better that dynamically allocate more traffic, more patients to the winning variations. And that's why this approach is kind of dynamic and learn from experience. And at the end of the day, like in this example, testing for 3 weeks, 50% of the time is losing in A/B testing, but using the bandit framework, you can have 85% going with the winning variation and just 15% with the losing one. Um, if you are asking yourself why bandit, what is it? So it's coming from slot machines where you have unlimited amount of coins, and you want to test each machine and see which one gives the best reward. And this is how you go from machine to machine, pull and find which one is the best. So I don't know, this is how this bandit names was mentioned, and after that everyone was citing bandit as a framework. So that was the intuition. The BanditDB came from the idea that we were testing different prices with on different contexts. Like, for example, there are different prices during the weekend. It might be competition, it might be some holiday that we need to change the prices. And we were using Postgre database. We were calculating the machine learning part on Python. And then we have Java orchestration. And I was like, this is too much for something that uh, could be put in a database. And that was the original idea. So what is what BanditDB is doing is to create a campaign, and then via curl, for example, to give recommendation, and after giving recommendation, the user gives some reward, and this is how the BanditDB updates itself. The database is written on Rust. It's in-memory database. There are two models that are currently implemented. This is LinUCB and Thompson Sampling. And there are three files that are recorded on the disk. Persistent. This is write-ahead log that every interaction is saved on the disk. There is a checkpoint about the calculations, and there is one Apache Parquet file, which later can be used to train a transformer model. And I'm going to show you the Hello World example and why this is applicable. And our Hello World example just a second. The example is about sleep improvement. So if you want to improve your sleep, you can either decrease temperature or decrease light or decrease noise. And we have made one campaign in the database called sleep. And for that sleep, we're going to measure how people react on different decisions. And we are checking how they react and record their response. And this response then update the database. So here we have we are tracking the gender of the person, the age, weight, activity, and bedtime. And for example, we provide that vector to the database, and we ask what would you recommend. The engine is giving decision to decrease light, and when we sleep and check how many hours of deep sleep, it's actually one or something, 1.5 hour of deep sleep, we can say this is helping us, and we give quite a big reward, or this is not helping us, and we give small reward. And after giving that reward, the model updates itself, and next time when similar profile wants to have an intuition and to decide what to do, the database is giving better and better outcome about this this profile. So it might be like old guy that is not doing any sport and is getting late to bed. And the prescription will be, for example, to decrease light. Any questions so far? Yeah?
So you're not just doing pricing, you're also doing categorization in many different fields.
Yeah. It's not related to only to pricing, but to its general purpose. I mean, you can put it, for example, for fraud detection. Right now, we have a friend in LA that wants to ship packages, but sometimes the packages are returned or they go to a ghetto and people are not paying. So if you know the profile, you can take decision based on the reward or on the penalty that an operator is giving to the database.
Just one more question. Can you take categorical inputs, not numerical?
No, it's just values between 0 and 1.
Numerical, so it's a linear model underneath.
Yeah. So yeah, I'm going back to the model and to the math. So it's a, let's say, hybrid database that is using one inverse matrix and two vectors, and this is for each decision. So we have linear dependency between the rewards and the context that is given, and we have actually dependency. We're searching this data vector that is product of inverse matrix and the vector of rewards. And the good thing is that if we compare BanditDB with any vector database, so imagine you have a rack system and you put lots of vectors. They are stored on the hard drive, and here we need to have only one matrix for the decision, and we store one vector. And anytime we get a reward, the matrix updates its values. Also, the B vector updates its values, and the multiplication produce the theta vector. And this is quite condensed knowledge in the memory, and you don't need to have big vectors or big matrices. This is quite enough, and is giving decisions after a few trials. So for example, for clinical trials or for dynamic pricing, we don't have so much people to experiment with. We're not training games on 2 million games to play Pong. We have like 100 or 500 people that we can test, and we need to be super sample efficient, and that's why those kinds of models are called fast reinforcement learning. So yeah, they don't need so much trials uh, to get this linear dependency from the context and the reward. And I'll show you how this is stored. So this is the write ahead log. Anytime the engine is giving the prediction, it provides one ID, and after that there is a delay mechanism which waits for the reward, and it can wait for 1 day or for 1 month. So let's say you're using it for clinical trials. You give the medicine to a certain profile, and then you expect to see how will be the reaction of that profile. and it may take like 5 days or a week. That's why the engine is waiting and giving reward for the ID that was drawn from the database. Um, the other thing that we store on the disk are the matrices and the vectors, and we are not writing everything on the disk. So once we have write ahead lock, that is, it could be like for 2 hours or for one day. The file size is not that big, because once we have the matrix and the vector, we can restore the database, get the write ahead log, and go to the previous state. And yeah, the last thing is this I didn't know in English that Parquet is not Parquet, but should be Parquet. So this is Parquet file, which have propensity, and it records all the probabilities on each step. And those probabilities that are recorded um, are needed for another thing, that is causal inference. So going back to the hello world example with sleeping, the model has already learned that decreased temperature is the decision that is already learned. So we have had like 300 trials, and this decision is learned. The other two, decreased light and decreased noise, are not learned. Also, decreased temperature usually helps 61% of the people, and the activity, let's say if the people, if the profile is highly active or not, have the highest weight on the decision. So whatever you are doing, you have something that that have something proven, something is certain. The other decisions are not certain, but they're still in a learning mode. What is the setup of the database? Very simple. As I told you, you need to point to the data directory, so that write ahead log, the checkpoint, and the Parquet file are recorded. It could have API key. Then we have rewards, and here we have 1 day as a default value that we can wait for rewards. The checkpoints interval, we have maximum size of the write ahead log, and that's it. We have it as a Docker file. We have the binary, and the last thing is the schema of the database. So we actually don't have schema. We have something that is kind of flexible JSON meta fields, where you can describe the process, what you're actually measuring, trying to understand, trying to get intuition about something. And the last thing actually is that we use BanditDB for agents. We have MCP protocol and server, and it have like two endpoints: get intuition and record outcome. And this is how agents and multiple agents can share intuitions about different phenomena. Um, so, for example, if you're writing an agent and you have multiple tools, once you have some task to do, the agent should choose which tool to use in order to get the job done. So you can use the database to store the reward uh, after uh, after the agents get intuition, and this is how all the agents will understand uh, what is working for some scenario and what is not working, and update the intuition. And next time when some agents wants to get some idea of something, uh, is pulling the intuition and the engine is giving the best outcome so far. So that's the database. uh, we're using it for pricing, and the other thing, as I told you, is this fraud detection. It's quite new. We built it last month, so this is like first presentation of the database. Uh, it's working with Cloud desktop, and here I have a campaign for selling ASICS shoes. I put different price, 45, 50, and 55 euro, and after uh, some time I understand what is the correct price for that ASICS campaign. And yeah, that's it. Thank you for your attention.